solution, but we can actually graph linear inequalities to show all the ordered pairs that are solutions. So here are some steps. First of all, just like with linear equations, we need to write the inequality in slope-intercept form. Just remember, slope-intercept is y equals mx plus b. After that, we are going to graph the inequality. Now, when we did inequalities on a number line, remember if we graphed it and it had an open circle that was less than or greater than. So in this case, kind of similar to the open circle, if it is an equal, or excuse me, a less than or greater than sign with no line underneath, we're going to use a dashed line, similar to the open circle on the number line. If it is less than or equal to or greater than or equal to, so it has a line underneath, similar to the closed circle on a number line, we're going to have a solid line on the graph. Now step 3 is going to be where we figure out what side of the line to shade. If you see that example, we have a shaded section of that graph. So in order to do that, we're going to use a test point to determine which side of the line to shade. Now I mentioned we are going to talk about 0, 0 again. So usually if the line's not going through the origin, we can use that as a test point. And you're probably thinking to yourself, why would you use 0, 0? Well, just like in this previous example right here, zeros cancel like a lot of things out because anything times 0 is 0. So that's going to make calculating pretty easy on us. So let's take a look. We're just going to do 1 through 4 together. Number 1 is nice, already in slope-intercept for us. So let's go ahead and graph it. It might be a little bit challenging to graph on this example, but we know -5 is the y-intercept. So start with your point there, and then we have a slope of positive 1/3. So we're going to rise 1 and go to the right 3. And then we're just going to keep making some more points. Rise 1, run 3. You could go down and to the left. You can put a point there. So your equation, or excuse me, your line, again, it's a little bit hard to do here. The line's going to look something like that. Now, we already talked about how there's more than one solution. And if you look at this example, we're going to have something that looks like that. We need to figure out which side to shade, which is going to show us where our solutions are. So this is what I'm talking about with the test point. We are going to use 0, 0 as a test point. So we're going to do what we did earlier. We're going to plug in 0, 0 into my equation. So let's go up here. 0 is greater than 1/3 times 0 minus 5. Now you can see that because we used 0, 0, it's going to eliminate things. So it's going to be pretty easy for us to calculate that. So that reads 0 is greater than -5. So we got to think to ourselves, is that true? Is 0 greater than -5? And yes, 0 is greater than -5. So that means that 0, 0, this test point that we used, is a solution to that inequality. So because it's a solution to this inequality, all your solutions are going to be above that line. So you can just go ahead and shade above that line. Those are going to be the solutions. Now I just realized that I made a mistake. So if anybody can catch my mistake, look at my graph. You know, you're just kind of in the habit of just drawing solid lines when you have graphs like this, but this is a greater than sign, so there's no line underneath, so this needs to be a dashed line. So I'm just going to kind of erase some bits there. So it needs to be a dashed line if there is not a line underneath that inequality sign. Second example, again, is already in slope-intercept. So go ahead and graph it. Y-intercept of -1, slope of -2. So make sure you're getting your slope right. Make sure that line has a negative or positive slope depending on the number. So if I were to graph this a little bit more precisely, it's almost going through the origin, but not quite. So I'm going to use the origin again as the test point. So I'm going to have 0 is less than or equal to -2 times 0 minus 1. So we're going to get 0 is less than or equal to -1. So my test point, which was the origin right there, 0 is less than or equal to -1. That is not true. 0 is not less than or equal to -1. So I'm not going to shade on the side where 0 is, 0, 0. I'm going to shade on the opposite side. Because as we just saw, if you plug in 0, 0, it is not a solution. So I'm not going to shade on the side where 0, 0 is, because that'd be telling me it is a solution. All right, let's do 2 more problems together. Number 3 is not in slope-intercept, so I need to get it in slope-intercept. So -2y is greater than -5x plus 12. So if you remember back to inequalities, what I'm doing right now is I'm dividing by a negative number. Remember, when you are multiplying or dividing by a negative number, you have to flip the sign. So I just flipped the sign. So I have y is less than 5 over 2x minus 6. So there's my line. So that's what we need to graph. Again, make sure it is dashed or not dashed depending on the symbol. So this line should be dashed. Again, 0, 0 is going to be our test point. So when you plug in, you get 0 is less than 5 over 2 times 0 minus 6. So 0 is less than -6. Is 0 less than -6? No, it is not. -6 is less than 0. 0 is not less than -6. So, because that is not a solution, we are going to shade on the opposite side. Let's do the last problem together. Not in slope-intercept, so we need to make it in slope-intercept. So here I'm dividing by -4, so I need to flip the sign. -x over -4 is positive 1 over 4x. And then we're going to have -2. So we have our equation. So again, same steps. First thing is to graph it. There is no line underneath, so I'm going to have a dashed line. Test point is 0, 0 still. We're just going to use that every time, basically. So 0 is less than 1 over 4 times 0 is 0. or excuse me, 0 is greater than, so 0 is greater than negative 2. Is 0 greater than negative 2? It is. So 0, 0 is a solution, so I'm going to shade above that line. So that is going to be the video on linear inequalities. Again, just remember, it's very similar to linear equations. We need everything in the slope-intercept. And then we're going to use this test point, 0, 0. And we're going to plug that in to see if it's a solution. And if it is a solution, you need to shade the side where you had that test point, because the shaded region shows where the solutions are.